Matter and Energy in Ecosystems Unit Lesson 3.3, Looking for the Missing Carbon. Activity 2, Finding the Missing Carbon. Let's review responses to the warm-up. Which claim did you choose? What was your reasoning? Let's think back to the carbon game and the article from the last lesson. Can the total amount of carbon in a closed ecosystem change? The answer, no. The total amount of carbon stays the same. For example, in the game, there were 30 carbon tokens at the beginning and 30 carbon tokens at the end, even though the amounts of carbon in the different parts of the ecosystem changed. Remember, the article also stated that in a closed ecosystem, carbon can't be produced or used up, only moved around to different parts of the ecosystem. We can eliminate Claim 1 because it is not supported by what we learned in the last lesson. So we are removing Claim 1. The carbon that used to be in the air or abiotic matter is no longer in the biodome, so the total carbon decreased, which leaves Claim 2. The carbon that used to be in the air or abiotic matter is now in another part of the ecosystem, so the total carbon stayed the same. You'll use the sim to figure out what happened to the carbon that was in the air in the biodome. You'll try killing all the decomposers and observe what happens. Before you investigate the sim, you'll make a prediction about where you think the carbon went. Students make a prediction by answering the question and then begin the sim activity. Remember, energy storage molecules contain carbon, so if you're looking for where the carbon went, you can look for a place where the energy storage molecules are increasing. You may look at this in Info View or by looking at the graphs and using the Graph Molecules preset. Students, upload a screenshot showing what happened to the carbon that used to be in the abiotic matter. Then answer the question. Let's debrief the sim activity as a class. Was your prediction correct? Why or why not? What was the evidence that you gathered? We could say carbon dioxide decreased and energy storage molecules in living things decreased, while energy storage molecules in dead matter increased. Without decomposers, the carbon that is stuck in dead matter can't be transferred back into the abiotic part of the ecosystem. This is because decomposers get energy storage molecules from consuming dead matter and return the carbon to the air when they do cellular respiration. Because the total carbon in an ecosystem doesn't change, it moves between the biotic and abiotic parts of the ecosystem in a continuous pattern called the carbon cycle. You saw in this diagram in the Carbon in the Global Ecosystem article. The total carbon in an ecosystem doesn't change, but it does move between biotic and abiotic matter. In the biodome, carbon decreased in abiotic matter, which means it must have increased in biotic matter. As we observed in the sim, this increase took place in dead matter. End of activity.